The origin of the internet. How a failed login changed the world. October 1969, 3 months after humans first walked on the moon, 2 researchers tried to send a single word between 2 computers, 400 miles apart. A word 5 letters long. 2 letters made it through. Then the system died. That failure is where the modern world begins. The story of the internet is not a story about technology. It is a story about fear, about a Cold War that forced a superpower to rethink how knowledge moves, about a handful of people, most of them unknown to the public, who imagined something so large they could barely describe it, and about the accidents, the dead ends, the 2-word reviews and the failed logins that somehow added up to the most consequential invention of the 20th century. This is where it started. The year was 1957. A Soviet satellite called Sputnik passed over American soil every 96 minutes, beeping. That beep produced a genuine national panic. Americans stared at the sky and wondered if they were losing the future. It is difficult to overstate how much Sputnik rattled the United States. A rival superpower had placed a machine in orbit, the highest ground in human history, and there was nothing America could do about it. Overnight, science became a matter of national survival. Funding poured into universities. Children were suddenly told to become engineers. Out of that panic came a research agency called ARPA, the Advanced Research Projects Agency. Defense Department funding with one loose mandate: make sure the United States was never surprised by technology again. Then something ironic happened. NASA, the National Aeronautics and Space Administration, formed a year later and took most of ARPA's interesting work: the rockets, the satellites. ARPA was left searching for a mission. The agency pivoted, almost desperately, into a strange and unglamorous field: computer science. At the time, computer science was barely a field at all. Most American universities did not offer degrees in it. Computers were room-sized machines used by a handful of specialists for military calculations and payroll. The idea that these machines would one day be central to human life was not just unfashionable, it was, to most people, ridiculous. But ARPA had money, and it had a new director looking for somewhere to spend it. That pivot would reshape civilization. The first man to imagine the internet was not an engineer. He was a psychologist. His name was J.C.R. Licklider. Everyone called him Lick. He had come out of acoustics research, studying how the human ear processes sound. But somewhere along the way, he became obsessed with a different question. What if machines could think with people instead of just for them? In 1960, he wrote a paper called Man-Computer Symbiosis. It argued that the future of computing was not about replacing human thought, but about amplifying it, a partnership between mind and machine. At the time, this was a fringe idea. Computers did math, humans did thinking. Licklider saw no reason that should remain true. 2 years later, he took over a small office at ARPA, and somewhere between meetings, he began writing memos to his colleagues with an unusual greeting. Members and affiliates of the Intergalactic Computer Network. There was no intergalactic computer network. There was no network at all. Licklider was writing memos to a thing that didn't exist, describing in remarkable detail almost everything the internet would eventually become. Shared resources, remote access, cloud storage, digital libraries, commerce, online communication between ordinary people. The year was 1963. He called it intergalactic because he thought the scale was absurd. He didn't expect to see it built in his lifetime. He was mostly right about that. Licklider left ARPA in 1964, but before he left, he did something quieter and possibly more important than any memo. He handed his vision to a small network of people he trusted. engineers, scientists, young researchers at universities around the country. He gave them money, he gave them freedom, and he told them to figure out what came next. That network of people would eventually build the internet. His vision sat on his colleagues' desks. Then, in 1966, a man named Bob Taylor inherited Licklider's office. Taylor had a problem that sounded small, but turned out to be the entire story. He had 3 computer terminals in his office. One connected to a machine in Santa Monica, one in Berkeley, one at MIT. If Taylor wanted to talk to a colleague in Santa Monica, he used the Santa Monica terminal. If he needed MIT, he stood up, walked across the room, and logged into a different machine. 3 terminals, 3 separate sets of passwords, 3 incompatible systems. Taylor said, and we're paraphrasing only slightly, there should just be one terminal that goes anywhere you want to go. That sentence was the internet. He took it to his director, Charles Hertzfeld. He pitched for 20 minutes. Hertzfeld asked if ARPA could actually build such a thing. Taylor said yes. Hertzfeld approved $1 million in funding on the spot. Taylor later said it was the shortest meeting of his life. The project would eventually be called ARPANET, the Advanced Research Projects Agency Network. Its stated goal was modest: let researchers at ARPA-funded universities share expensive computing resources. The unstated goal was much bigger. Taylor, like Licklider before him, understood that once machines could talk to each other, everything else would follow. But first, someone had to make them talk. October 29, 1969, 10:30 at night, UCLA, Bolter Hall, room 3420. A 21-year-old graduate student named Charlie Klein sat at a terminal. His professor, Leonard Kleinrock, stood nearby. Their goal was simple: send a single command to a computer 400 miles north at the Stanford Research Institute. The machine in front of Klein was an SDS Sigma 7, a refrigerator-sized mainframe with 128 kilobytes of memory, roughly 1/200,000th of what a smartphone would carry decades later. It was connected to something called an IMP, an interface message processor, a kind of primitive router the size of a filing cabinet. The IMP would break Klein's message into small packets of data and send them up the coast through leased telephone lines. None of this had ever been done before. Nobody knew if it would work. The command was login. Charlie typed the L, he picked up the telephone, yes, the telephone, and asked the team at Stanford, "Did you get the L?" "Got the L." He typed the O. "Did you get the O?" "Got the O." He typed the G. The system crashed. The very first word sent across the ancestor of the internet was 2 letters long. Low. Kleinrock, decades later, would call it prophetic. Low, as in, lo and behold. But in the room that night, nobody was reaching for poetry. They were trying to type the word login, and the system had quit on them after 2 letters. There was no camera, no tape recorder, no photographers waiting in the hallway. The only record of the event was a handwritten line in a lab logbook, an entry so understated it reads like someone documenting a dentist's appointment. 22:30, talked to SRI, host to host. Nobody in that room believed they were making history. They were debugging. An hour later, they fixed the crash. The full word went through. The network was born. Within months, more nodes joined. UCLA, Stanford, UC Santa Barbara, the University of Utah. 4 computers in the western United States, now able to share data across hundreds of miles. By 1971, the network connected 15 sites. That same year, a programmer named Ray Tomlinson, working on a separate ARPANET project, wrote the first email program. He needed a symbol to separate a user's name from the computer they were logging into. He looked at his keyboard and picked one almost at random, the @ symbol. By 1973, ARPANET had crossed the Atlantic. The Norwegian seismic array in Kjeller became the first international node, followed by University College London. What had started as a research experiment between 4 American universities was now, quietly, a global system. A network was one thing. A network of networks was another. By the early 1970s, ARPANET was no longer alone. Other networks were being built, some by the military, some by universities, some by private researchers. Packet radio networks, satellite networks, experimental systems in Britain and France. They all worked. None of them could talk to each other. It was the Tower of Babel, rebuilt in silicon. 2 men solved it. Vint Cerf, a young professor at Stanford, Bob Kahn, a program manager at DARPA. They had met years earlier working on ARPANET, and they understood the problem better than almost anyone alive. Working together, sometimes meeting in a hotel near the San Francisco airport, they designed something called TCP/IP, a common language that any network, anywhere, could speak. The beauty of their design was its humility. TCP/IP did not try to control anything. It did not care what kind of network you ran, what kind of computer you used, what kind of data you sent. It asked only that you speak the language. The rest was up to you. They coined the word internet while they were at it, short for internetworking of networks. Cerf once explained why they couldn't just run the military's communications over phone lines. The tanks run over the wires, he said, and the ships get all tangled up. That was the world the internet was built for. A world where infrastructure was fragile, where war could come at any moment, where the network had to survive damage and keep functioning anyway. The open, decentralized architecture of the modern internet, the reason no single country or company can fully shut it down, is a direct inheritance from that Cold War design requirement. On January 1st, 1983, every machine on the ARPANET was required to start using TCP/IP. That date, which almost nobody at the time noticed, was the closest thing the modern internet had to a birthday. The original ARPANET was formally decommissioned in 1990. By then, it had already been replaced by the network of networks it helped create. One last piece of the story. A British scientist named Tim Berners-Lee was working at CERN, the European Organisation for Nuclear Research, a massive particle physics laboratory just outside Geneva, Switzerland. Thousands of scientists from more than 100 countries passed through its doors, all trying to answer the same basic question: what is the universe made of? His problem was librarians' work. Physicists from around the world needed to share documents, and the systems for doing so were a mess. Different computers, different formats, different file systems, information trapped in silos. Berners-Lee had an idea. What if all documents, everywhere, could link to each other? What if a researcher in Japan could click a word in a paper and jump instantly to a related paper in Switzerland, as easily as turning a page? In March, he filed a proposal to his boss describing what he wanted to build. He dated the document the 12th of March. He chose that date, he later admitted, because it was his mother's birthday. His boss, Mike Sendall, read the proposal. He wrote 2 words on the cover: vague but exciting. Sendall did not approve the project. The proposal sat for over a year. Berners-Lee revised it, resubmitted it in May of 1990. This time, Sendall did something clever. He didn't approve the web, but he approved the purchase of a powerful new computer called a Next, justifying it as a test of the equipment. Officially, Berners-Lee was evaluating hardware. Unofficially, Sendall had just handed him the machine he needed to build the world's first website. By September 1990, Berners-Lee was working on it full-time. By December, 3 months later, he had a working web server, a working browser, and the world's first website. The entire infrastructure of the modern web, HTTP, HTML, URLs, the browser itself, had been built by one man on a single computer in a particle physics lab in 3 months. He taped a handwritten note to the computer in red ink. "This machine is a server. Do not power it down." He called it the World Wide Web after rejecting Mine of Information, whose acronym MOI means me in French. Working in Geneva, he thought it sounded egotistical. He also considered information mesh, which he rejected because it sounded too much like mess. The web spread slowly at first. By the end of 1991, there were fewer than a dozen websites in the world. By 1992, there were still fewer than 50. Berners-Lee could have patented his invention. Companies were beginning to build competing proprietary systems. Microsoft had its own ideas. In 1995, the company launched the Microsoft Network, a private, paid online service pre-installed on every copy of Windows 95. With Microsoft controlling roughly 9 out of 10 personal computers in the world, MSN could have become the biggest online service on Earth almost overnight. Bill Gates was openly betting against the open web. AOL was already there, a walled garden. Millions of subscribers paying monthly to access a curated, company-controlled version of the internet, with very little of the open web inside it. Most people who used AOL believed AOL was the internet. If the world's most powerful software company and the world's biggest online service had their way, the internet would have looked nothing like the one we eventually got. It would have been a network of private kingdoms, owned, paywalled, curated, controlled. The web was the alternative, and it was very nearly stillborn. Then, in April of 1993, CERN did something that almost no one at the time understood the significance of. They released the web for free into the public domain, forever. No license, no royalty, no owner. That decision is the reason the internet became a public space instead of a private one. It was a decision made by a research institution in Switzerland with a signature on a single piece of paper. It was almost certainly the most valuable thing anyone has ever given away. Within a year, there were hundreds of websites. Within 2 years, thousands. By the end of the decade, millions. The world had found its new common space. So what was it in the end? An agency built from Cold War panic? A psychologist writing memos to an imaginary network? A pitch for $1 million delivered in 20 minutes? A graduate student accidentally sending the world's first digital word, a word that turned out to be a crash? A common language hammered out by 2 men in a hotel near an airport for a world where tanks ran over wires? And a British physicist who filed the founding document of the World Wide Web on his mother's birthday. The internet was not designed. It was discovered, in pieces, by people who did not know what they were building. Licklider never saw it finished. Taylor watched it grow from his office. Klein typed its first word and went home for the night. Cerf and Kahn wrote its grammar. Berners-Lee gave it a face. None of them got rich. None of them asked to. Every generation builds something it doesn't fully understand. The people who built this one thought they were helping scientists share papers. Instead, they reshaped how their species talks, argues, works, falls in love and goes to war. The artifact keeps growing. Most of its builders never saw what it became. But that is always the way with the things we dig up. The builder rarely lives to see the ruin. This channel is about systems. The ones that were built decades ago and still run everything. The ones being built right now that nobody is watching closely enough. We will cover them, one at a time, the same way we covered this one. Thank you for watching.